Welcome back to our session on PPM applications. It's about time to get it started. For those of you who are just joining us, my name is Roberto Orbulu, and I will be the facilitator during this session. Perhaps a bit of recap. In the previous session, we focused on how project production management is being used in design and engineering. We heard very interesting and proven success stories from speakers representing Hess Corporation, joining us from Malaysia, Tripatra from Indonesia, one of the largest EPC contractors in the country, McKinsey and Company with Jan Coleman joining us from the Netherlands. And finally, Alex Koons from AG Koons represented, telling us more about integrated design and construction. But now the focus is on the application of PPM, focusing on how PPM is used to improve supply and construction. Like this morning, we're going to be joined by several experienced speakers from many leading companies who will share with us basically three things. One is why they have adopted project production management. What is the reason, the business reason, some of the challenges that they have approached, how they are actually implementing it, and how they are benefit from it. Okay, we have four speakers. We have Tengiz Chevron, we have McKinsey and Company as well, Chevron Corporation, and Microsoft. Each speaker, as we did this morning, will be assigned half an hour, out of which 20 minutes will be focusing on delivering the presentation, and the remaining time, up to 10-minute maximum, will be for questions and answers. So let's get it started. Without further ado, our first two speakers represent Tengiz Chevron, or TCO, as the company is known. It is a joint venture between Chevron as the operator, ExxonMobil, Kasmunai Gas, or KMG, and Luke Arco. Right? TCO is one of the largest oil and gas consortiums in Kazakhstan, but also in the world. So we invite Darina Saakashvili and Ludwig von Robenheimer to please proceed to share your video and enable the audio, if you don't mind.
Hi, Roberto.
Darina, how are you? I know it's very late for you. Connecting from Kazakhstan, and Ludwig, thank you. Ludwig, if you can check your background, the PPI.
Hey, good morning, good afternoon, Roberto.
No worries. Okay, so with that being said, please allow me to introduce Darina and Ludwig. Something important to highlight before I go through that, by the way, is that Darina and Ludwig are working in two different projects at two different TCO projects. They are both applying computer-aided production engineering, or CAPE, as it's sometimes called, at different project stages. So they bring a combined and a very interesting story about how CAPE has been applied in construction and how CAPE is being applied in early engineering, okay? But first, let's go very quickly through some backgrounds. Darina, let's start with you. Darina has been the project production management lead at TCO, at two TCO projects, the Northeast Ring project and the KTL switchgear, where she's currently working on. She has spent the last 15 years in TCO's Capital Projects organization and has held a variety of roles, including the deployment of the Chevron project management system across the portfolio of major capital projects in TCO. Darina holds a bachelor degree in petroleum engineering from Kazakhstan University. So thank you, Darina, for joining us and welcome. Ludwig. Ludwig is currently the productivity manager for the gathering system team at the TCO Future Growth project in Kazakhstan. He has extensive experience in continuous improvement strategies and processes, who he has been able to apply to several Chevron projects in the last 10 years. Ludwig holds both a master's and bachelor's degree in industrial and systems engineering, and is currently enrolled in an MBA program for logistics and supply chain management. He's joining us from Perth, Australia. So thank you very much to both of you. And I request, please, that you, Ludwig, I think you're going to be the one sharing the screen. I will ask you, Ludwig, to unmute yourself. Darina, please remain muted until it's your turn in the presentation. So from here, I will leave you the stage to you, Ludwig. Thank you.
Yes, thank you for that introduction, Roberto. So again, thank you all for the opportunity. So today I would like to talk about how we apply computer-aided production engineering at TCO. I would like to take you through our experience on two of the projects that we are applying the CAPE technology and the methodologies. So on the one side, a greenfield project where we're using CAPE during construction, and on the brownfield project where we are using CAPE during early engineering. For the greenfield project, we're focusing on the installation of pipelines, and in particular around the use of crossings. And then on the brownfield project, we'll be focusing on the cutover side of the implementation. So today we would want to share with you why CAPE. You know, what's our drivers? You know, why do we want to innovate? Why do we want to look for better ways? And talk about the application of CAPE within TCO. We would also want to talk about what we mean by CAPE, what it is and what it is not, because sometimes there's a confusion about what is CAPE and how do you apply it, and what does it consist of. And then we want to take you through the journey we've taken to invest time and energy in CAPE, both on the construction and the engineering side of TCO. And then at the end, we want to close out with some lessons learned, and then open up for some discussions. So first of all, why CAPE at TCO? So we all know that projects are quite complex, and the projects we are working on are particularly complex with a lot of challenges, and we are driven to have an excellent execution, and we are striving to have a next to none project performance to ensure that we can deliver our complex scope in time. We want to be more effective by handling the complexities and the risks at the execution level. You know, we have plenty of those. We have interfaces with our brownfields. We have interfaces with our operations. So there's careful coordination to align the complexity of the operation as well as the risks of you know, what we can experience in the field. We then want to be able to better define and design how we do field operations before we actually execute them. So we want to get the test drive, the what if capability before we actually go test that in the field and run into trouble. Because once you're in the field and start executing, you don't have a lot of options to do trial and error. Outside of the field area, you have the option to do some trial and error beforehand and then decide on the best way forward. So that's part of the why CAPE is important to us. And then we want to be able to say how best is it simultaneously design the asset and the process to build, and then use that knowledge to applied to the next operation and for future applications. So what are we implementing? So I want to take you through the process of CAPE and then highlight certain elements of what CAPE is and what CAPE is not. So let's talk about what is CAPE. So CAPE is about designing and optimizing field operations. You know, whether it's repetitive or whether it's once-off, where you want to get a clear understanding of the complexities and you know, the intricacies of complex engineering or complex process where you're not 100% sure how that's going to be applied in the field. You've got one chance in engineering to get it right. We all know how costly it is to fix a engineering problem after the fact. So we want to make sure that we have the right process when we implement and the right product when we implement that once we go to the field. What CAPE is not, it's not really a constructability review, you know, and to look at the interfaces. That's done by construction. This is more getting hands-on, trying to understand what we can expect from the process when we execute. So there's a couple of elements that's applied. You know, we use key enabling tools. We look at digital prototyping of the process so that we can actually visualize how we're going to do things in the field. We don't want to go in blind and just look at a flow chart and not really see the interaction of the different elements. We really want to have a feel and a visual on how this process gets applied and get executed so that we can see if there's any constraints or any inconsistencies in the way that we expected the execution to run. One of the other enabling tools we are using is the Chevron Production Manager, which allows us to control work in the field, how we execute once we have a process in place, to then do our daily plannings and start to run a process on a day-to-day basis. Once we have all of that, we then run through the improvement cycle to try and work out. I will talk to you about the first run study element in one of the next slides, but to sum it up from a production engineering perspective, we are also looking at ways on how do we engineer the process and the product for production. If we are driven for excellence to get project performance, we want to enable the execution side of things to be driven and drive production performance. So this is where we all started. About a year ago, we looked into one of our first applications of CAPE, and this is a complex network of expansion loop boxes, about 93 of those, and you can see the little arch in the top left photo, which is a visual of the part of the model. But we had to do about 93 of these boxes, which consist about, if you lay it all out of all the individual parts, it's probably more than 10,000 individual pieces to make all of these boxes. So we really understood the complexity when we looked at the scope, and we wanted to get in early to try and get a good view of how we're going to execute this. It's a high risk because of a lot of lifting, a lot of heavy precast equipment, a lot of touch points with human interfaces and heavy equipment. So we wanted to understand the risks and the constraints early on. What we were able to do with the early implementation is we were able to reduce our cycle time by about 30% from the start, because we did a lot of our initial understanding and testing outside of the field. So we had a good visual on the execution, we had a good visual on the potential risks, and we streamlined all of that before we took a lot of the work to the field. When we did the study, we identified specific design issues that was constructed by the engineers to, where they thought the design would be better off with some of these changes. And when we highlighted some of those, we recognized that it's probably not needed because of the weight and the size of these equipment. We don't need to include all these smaller details that is there to aesthetically align some of these boxes. So which I'll show in the next slide. You know, in addition to the engineering design issues, we also identified some fabrication related and construction improvements during our first run study. Now, our first run study is all about getting us a good understanding of the cycle time, the process, the execution, the sequence, and it gives us the ability to gain a insight knowledge of how this sequence is going to be executed when we apply that in the field. So the first run study on the expansion loop gave us a lot of insight on what to expect when we go in. On the bottom left-hand photo, you can see some of the special design tools that were created to move some of these equipment. Now, one expansion loop box takes about between 35 and 40 of these individual pieces of precast concrete. Precast concrete weighs between 5 to 9 tons, depending on the size. And if you lay it all out, there's about 3,330 of these individual precast boxes that needs to be lifted multiple times from the way that they've been fabricated, and precasted, when they moved into a laydown area, when they moved into the construction location, when they moved into the actual construction site where they are being installed. So there's multiple touch points with these heavy crane movements. So let's walk you through a bit about the how we designed the process. So you know, I talked about visualizing and testing the design of the process. So on the left, you can see how the design of a expansion loop came about when we utilized the model. Now, one of the things I need to highlight is that you all might think that this is all done by engineering before you actually do this. This was actually done post-engineering, and we utilized 2D drawings from the engineering department to generate a model. So it wasn't part of the engineering exercise. It was getting ready for construction when we picked up this scope, and we utilized the technology to generate the 3D visualization for us, and we overlaid the individual process steps to then able to walk the process and try and see how these individual pieces will be connected to be implemented. On the right-hand side, you can see the visual exposure we had when we did the first run study to test, you know, to get each one of these box pieces in line and implemented. And the third one there on the right, you can see that we had one of these little rods, they call it like a spacing dowel, to that the engineers thought that if we install these little dowels at each one of these boxes, we can then very easily navigate the boxes in, like typically what you will have in a Lego set, where you need to do a unique attachment of components. You have then a little guiding rod that allows you to fully center the two pieces. We immediately saw that as being a high safety risk, because that creates a pinch point for the individuals that's there, and also this dowel wasn't properly designed from the way it needed to fit. So when we flagged that with engineering, they recognized that we don't probably need that. So we took that out, and that created some additional savings, as highlighted on the previous slide. So part of our design and visualization of this process, we very clearly look at the process and sequence digitally inside the computer. And you know, once we have that good understanding, we then went to apply that physically, which you see on the photos before we go into the field. by doing all these things together, we gain a good understanding of, how the product design has been done, and how does the process design now need to take into account what the product and how the product need to be implemented. In line with these studies, we also then gain a good understanding of the typical capacity of resources that we need to use, how many equipment we need to apply, and how complex it's going to be to implement once we're in the field. And then, what would be the rate of these boxes that we had to get into the field in a certain point in time, because where the fabrication yard is and where the site is about a 2-hour round trip. So if you have 35 boxes to 40 boxes, you can only carry about between 2 and 3 of these heavy concrete precasts per truck transport. So you have to logistically work out how many of these boxes do you want in the field, and build some inventory so that you can actually assemble the box and don't delay your usage of your shared resources when you're in the field. So that gave us good understanding, and then obviously the ability to understand where we can expect some of the variability that may occur when we start to execute the construction piece. So that's giving you some visualization and how we tested the process up front. Now, since we've implemented started constructing the expansion loops, we recognize that we may want to utilize the same functionality in our pipeline crossing scope. Now, the pipeline crossing scope is probably one of the largest networks of crossings, and we have to do about more than 4,000 crossings across the entire landscape of where we work with implementing our pipeline. So on the left-hand side, you can see a very detailed network of a complex net of these crossings. And we basically have 3 main types of crossings from an execution perspective. You get the open cut, you get the above ground, and then you get the trenchless crossing. Each one of these types of crossings has a different complexity element to it, as well as a different execution method from the equipment that they use and how they go about to implement the crossing to ensure the pipeline is able to continue its mainline construction to meet up with the particular crossing element. Some of the challenges.
Ludwig, we have 5 minutes left, just for your consideration.
Okay. So part of the key specifications that we have is that we had to consider. We had to consider dynamic SIMOPS, complex concentration of crossing types, and then the execution strategy for critical operational shutdown schedules. That's all impacting our ability to execute. So we were looking at the analysis of the process design. We know the cycle time is highly variable due to specific site constraint, due to dewatering elements that's different at each location. Our productivity is not always where we want that to be, and we know that this is part of our critical path scope to complete the pipeline scope. So, the process is a interconnected set of activities that lines up how we want to execute that particular process. From a 4D visualization, we wanted to test, is the process then robust enough? Is it optimal? How do we apply? How do we see if there's any specific items that we've missed? So we would create a digital prototype of the permanent components, debris components, and we would run through the process and then see how they interact to try and spot, from process design, have we considered all the sequences, the handoffs, and the SIMOPS, and then have the ability to run through that model. So in essence, looking at having the model available to us now allows us to very quickly spot constraints with the different elements, and we are then able to educate our workforce on those potential constraints up front and then streamline the process as we implement. I would like to now hand over to Darina so that she can talk through her experience from a brownfield project perspective.
Yeah, thank you, Ludwig. Thank you, everyone, for an opportunity to present. So I and our team have been also lucky to leverage SPS technical team support to take our team through the CAPE process and witness and experience eye-opening benefits from the CAPE. So to allow you to explain the rationale why another TCO project made a decision in favor of CAPE, let me give some brief highlights of our project. Our project is a brownfield project and has been tasked to complete about 2,690 volt hot cutovers during the live operation of the plant. So in other words, if we cut the wrong cable, we will shut down the entire plant. So the facility where our team is going to complete the cutover is 30 years old facility. And there are no spare parts for any of those equipment. There have been several arc flash events in the switchboards, and due to the obsolescence of the equipment, replacement in kind is not possible. So on the next slide, I'm going to talk about the initial field data and the designing the cutover field operation. So in 2019, our project carried out the test to check the feasibility of splicing to obtain the duration of main stages of the work. When I saw the initial field data with the splicing test results, I assumed that the team was aligned and there will be no problem while developing the workflow. So then we, as a team, we have decided to develop a cutover standard process that is a workflow, which looks like a schedule on your on the right-hand side, but it is not a schedule. It is a workflow of the cutover process, but from workers' standpoint of view. So usually when we are developing a standard process or workflow, we selfishly think from a management standpoint of view. But here, while developing the workflow for CAPE, we had to think, put ourselves into the worker. So as Ludwig mentioned previously, product design is interlinked with process design. If product design changes, then it impacts the process design and the vice versa. We were not able to finish the development of a workflow in one day, as assumed at the beginning. It took us a month to make sure that everyone is producing the movie and we would like to watch the same movie. During the product design, we haven't realized the sources of variability and capacity, that there is different like an inventory and capacity, like number of crews, whether the crews will be working simultaneously, what type of equipment we have to use, like a multimeter, ohmmeter, Megger test, insulation resistant test, and that there might be different cables, PVC cable, XLPE cable, those sources of variability. Having realized different sources of variability, we have developed one design of the process for cutovers that we can move forward with. However, since we currently our project in phase 2 and just moving to FIT, I cannot say that the current process design is final. For us, it is an iterative process. So which means more design, more engineering is done, more data will be fed and will be fed into this process, and which we will use to refine the process design. And we can better address the variability in these early stages.
We have 2 minutes left, Darina, if you don't mind getting to a closing remark.
Yep.
Thank you.
So on the next slide, we wanted to show the current conditions of the product existing infrastructure from the point cloud. We are currently refining the process and understanding the interaction between the point cloud and the product design. The advantage for us for doing the CAPE for our project was that we could overlay the model on the point cloud data, and we have realized how congested the area is. Our assumption that we were going to use 3-4 crews working simultaneously won't work when we having seen this product design. So on the next slide, you will see that that we are taking it to the next level. We are currently creating 4D animation, which is on your right-hand side at the early stage, that allows us to validate if the processor is robust. And if the process is not robust, we are going to identify the weakest points and go back and redesign it. So that is the loop which you see from the workflow back to the process, and from the point cloud data to the workflow. So it is not, for us, it is not a single event, but it is an evergreen process. Most of the engineering efforts focus on developing the engineering. Where we have decided to do is to take it to the next level by developing the 4D visualization from the workers' point of view. Here you see that red cables are the existing old cables, and the green cables are going into the new substation, and the cutovers will be done on the top of the rack. And we have put scaffolding, which we have to erect in order to complete this work. And there's people who are standing next to the consumers, and there's a person who is using the boom track to make sure that he is completing the work. So the next slide, I think we are going to talk about the lessons learned here. So Ludwig, would you?
Yeah, so thanks for that, Darina. So just to summarize, from what we were able to learn. So obviously, integrating the model with the process has allowed us to reduce the variability, and understanding, what the constraints are from the product and process design perspective. It gives us the ability to focus on key areas and take the required actions and mitigations early on to further improve the cycle time, and increase the throughput. We wanted to use the learnings and experience from the execution reality, and we are using that to inform the model to allow us to implement further improvements and redesigning the way we do things. And we are learning about the issues we had with the sequencing related to dewatering and backfilling operations within our crossing scope.
So from our project standpoint of view, what we have learned on our projects, that we were not aligned on the process at the start, and we had to take several reiterations to agree on a workflow. But at the end, every entire team, like an electrical team, project team, has been aligned, and now currently we have a good workflow. And there's another advantage was that CAPE has identified a lot of risks, bottlenecks, uncertainties, which the project team is going to work during the fit stage. And also another advantage was like we could overlay the model on the point cloud data, which allowed us to see the complexities of our brownfield scope of work, and which we will face during the cutover.
Thank you so much. And I purposely allowed a little bit more time for you to finish your presentation. Just for our audience, we do have some flexibility on timing. As Ludwig and Dorina has shared with us, you know, we just experienced some variability. So, but we're going to use some time buffer in order to address that. Ludwig and Dorina, thank you very much for your stories. Even though we don't have a lot of time, I would like to take you through a couple of questions that we're getting. We got several questions, but let me take one, and this is for you, Ludwig, it seems. The question is, you reduce cycle time by 30% in one of your applications. In parentheses, it says loops. Do you think there is more to gain, right? For instance, do you think we can reduce the cycle time even beyond 30%? What are your thoughts?
Yeah, good question. So I think to recognize the 30%, that was done on the first 11 boxes. So we have about 82 to go. So I do think that we have some additional opportunities to improve our cycle time, and getting into out of the winter will give us a lot more to work on with the spring campaign. So you know, once we get through the pandemic, that would allow us to progress with that scope of work that's been impacted this past year with the pandemic. But I do believe that we'll have additional cycle time savings.
Thank you so much. And I think we have one more here. This time, this might be for you, Darina, based on the context of the question. The question is, it's like a mix of comments and questions, I guess. So very impressive application in an early project stage, someone says. Something that took my attention was your point about concurrency of process and product design. However, in early engineering stages, the design is not yet fully completed. The question is, what challenges did you face with this, and how did you and your team address them in order to do what you did?
So our team, as I mentioned, our team even completed like a pilot cutover execution on field. And they assumed that they have identified everything and they know exactly how to execute the cutover strategy. But unfortunately, when it came, when we had to develop this workflow, we had to identify a lot of issues and the bottlenecks, which has been like taken as an action to work during the FIT. And now another effort which we are taking right now, based on Craig Evans' guidance, we are going to use a drone to do the survey around the plant and to identify, to get the answers for the questions which we don't know the answers to.
Okay, and there's one more, I think this is for both of you, just to wrap it up. The question here, let me see if I get this right. If you haven't done, let's say that you haven't done CAPE, how do you think you will have done what you have done? What is the alternative way?
I think in our case, we would have taken that pilot cutover strategy as like as a Bible, and we would use that during FIT. And I believe we would, during the execution phase, we would face a lot of problems with the schedule and the cost.
Interesting. Ludwig, what do you think about that?
Yeah, on our side, I don't think we would have been able to achieve that early cycle time reduction, because we would have gone in blind to just run with the plans and then start to execute and lay out these individual boxes with all those additional engineering elements, and which would have created some extra complexities to execute, and potentially some safety related risks as well. So I do think it allowed us to firsthand see before we actually do it in the field. So it was a reality check a sort of insurance policy up front to allow us to test drive what we're about to step into in the field.
Excellent. Thank you very much to both of you. We do need to move forward. And so thank you so much, Darina and Ludwig, for being with us today. Very impressive work, I can tell you that. And now we're going to transition to our next session. So have a good day on your end. Thank you. Our next presentation brings a story of how McKinsey & Company has successfully applied production control to address significant challenges in construction. I invite Jim Banaszak. Oh, here we go, Jim. Thank you.
Hello, Roberto.
We can see you and we can hear you. That's great. So please let me introduce Jim. Jim is an expert partner for major projects in the capital productivity and infrastructure practice at McKinsey & Company. He is a member of the firm's global energy, materials, retail, and high-tech project delivery service lines. Jim earned a Master of Science in Environmental Engineering at the Illinois Institute of Technology, and he holds a PhD in Civil and Environmental Engineering from Northwestern University. I actually know Jim from quite some time, and he's a kind of guy with numerous stories to tell. And in addition of being, of course, very, very passionate about improving project performance. So I invite you all to hear one of his stories. Thank you for being with us, Jim, and please proceed to share your screen, and it will be over to you.
All right, let's see how this goes. Thanks, Roberto. Can everyone see that?
Yes, we confirm we can see it. It's all yours.
Excellent. Thanks, Roberto. Thanks, everyone, for joining this afternoon. A real pleasure to speak to all of you. As Roberto mentioned, I'm going to tell a story about an engagement that we had really the end of, let's say, the middle to end of 2019, moving into the early parts of 2020. The timing will be important, as you'll hear in a second. This is how we applied production control to a project recovery situation. So let me just set the context for this situation. So this was a long-standing client of ours. They were building a new facility in a location where they already had 3 operating facilities. So this was nothing new for them. There was a tiny piece of new technology going into this facility, but it was really just an improvement over what they had currently were operating on the site. But the situation was such that because of this new little piece of technology, and because of the markets that they sell into, they had to have the product coming out of this facility approved by their customers. And the test cycle for their customers only occurred once a year. So I'm sure many of you are familiar with this type of situation. You put a product out into the market, your customers want to test it. They want to qualify a new facility or whatever you might call it. That was the situation that we had here. It just so happened that the qualification only happened once a year, and that would be the second quarter of 2020. So we had the first thing that we need whenever we take on a project recovery, we had a clear objective. And that objective was to get the facility operating by the first quarter of 2020. We're talking now, you'll see we're starting back in April of 2019. I think the second objective is to figure out where you are, and that's what we're going to talk about here, and then how to achieve the objective as you see at the bottom. A couple of the other challenges that really caused the client to give us a call. Although this was a facility they had done in the past using technology they were familiar with, the OEM manufacturer and some of their sub-suppliers actually was having trouble meeting production targets. And therefore, the equipment was actually arriving late. It was arriving out of sequence. Sometimes was not arriving at all, which we'll get into in a second. And of course, as everyone knows on these types of projects with a lot of process equipment, you're always going to have the issues where something is broken, doesn't fit, has to be slightly modified or repaired. That was just par for the course. But the real root cause here was the out of sequence and late delivery of equipment. When we got to the site, the team was really not set up for this. The team was set up to do a cookie cutter approach to something that had been done 3 times before. The expectation was that everyone whom they had worked with before was going to be ready and perform on the project. When that didn't happen, things started slipping. And by the time we were called in and able to assess the project, we actually had a go forward schedule that said the project probably would not have been complete until July or August of 2020. So missing the window. Just to ground everyone here, we're really talking about production system control when we talk about a project recovery. We don't have the opportunity to map the process from the beginning, try to optimize sequencing of activities. We're really, handed the situation that we're handed. And, we have to start with that reality and then start chipping away at opportunities to actually improve the situation. So where do you start in this situation? You always start with the site walk, right? And we started with the site walk, noticed quite a few things about what was going on at the project. The project was not, disaster in the sense that it was, unmanaged, unkempt or anything like that. It actually looked like a well-run project for what was going on. But we did see quite a few issues associated with the setup that I gave you in the context that I started with. A lot of what we saw, you could classify as work in progress or inventory of work. I mean, if, I don't know if you can see actually this pump battery, it's actually well put together, except for the fact that the flow meters are missing out of sequence equipment. And, we saw many examples of this. Obviously, if you were to do an earned value on this picture on the left, I think we would all agree it's 99% complete, right? But not ready to do anything with. We saw this over and over again. We asked the question, so where are the meters? We got one of several possible answers. They're still at the factory. They're on the ship on, somewhere over the ocean. They'll be here soon. Or we can't find them. They've said they've arrived. And they're out there somewhere. And out there somewhere was the laydown yard where there was significant inventory material. So in addition to the inventory of work that was going on, because of the out of sequence delivery and the inability for folks to actually align the delivery of machinery and supplies to the project, there was a significant buildup of materials out in the laydown yard. And we'll talk about that some more. So, opportunities to improve for sure. Let's go to the next slide. I think this one's familiar to all of you. This is basically, the process for production system control, 5 major steps, nice linear process. We agree with all these steps. When you get into a project recovery situation, you have to run some of these in parallel. So the way we approach this is first, as I mentioned, align on the business objectives. So I already told you that this facility had to produce a test product by Q2, ideally end of Q1 of 2020. What does that mean? That means you don't need sheeting on the building. It means you might need utilities. You certainly don't need a crane. You can pick things up with a forklift or move them some other way, but you need the process operating. So our focus started on production, scheduling, planning, and execution for the process. So that was one piece of what the team started working on. The second piece the team started working on was thinking about how can we get ahead of this situation. And that's where standard process mapping and actual production planning can work in parallel with the 3 middle steps and actually help the team get ahead. So I think of the middle 3 steps as figuring out what the problem is, the closest problem that you have today. What is your today problem, and fixing that to the extent that you can, and tackle the next one, Root cause identification, mitigation, move to the next one. The process mapping, I think of the opportunity to get the team ahead. So look 3 problems ahead and try to solve that one as well. So, but the time we get to that 4th problem, we've already we've already solved it. And since we've solved our daily, weekly problems, by the time we mesh with the future problems, that's actually where you get the dramatic improvement that we were able to achieve. So I'm just going to walk very quickly through, the 5 steps, again, not in the order that you see here, right? Just based on the explanation I gave you. So production meetings, where are we? This is basically how bad are things? What's the problem? I think most of you have seen charts like this already during this session. We started at the beginning, right? 3-week look ahead, daily planning sessions, meet in the afternoon. How much did we get done? As no one will be surprised at this point, I think, in this session to see, initially we're at 48% commitment reliability the first week that we started measuring. You could see this growing over time. A lot of folks say, well, that's because the folks on the ground here are starting to figure out the game and they just promise less. Sure, there's some of that going on, but they also see that as they start identifying root causes, so the root causes you see here at the bottom right, and folks actually are assigned to and start fixing those root causes, these folks on the left start to believe that they can actually improve things. And yeah, they may pull back on what they promise each other and commit to, but they also realize that in the grand scheme of things, if this project is going to be successful, if we're going to meet the objectives, at some point we have to meet production targets every week or every month or every day. And the only way we're going to do that is by committing to getting work done to each other and improving our reliability on those commitments. So when we started measuring, as I introduced, not enough materials. Really, it's kind of vague, but it was a start. So it at least let us identify the first root cause of the problem of why this project was late, and that was inability to either find or lack of materials on site. So we went one step deeper. We now started mapping out activity networks for certain pieces of work. So again, only focus on critical path work, mainly focused on process and the distinct system turnover steps that will be required to get to commissioning, to get a product out the door by the end of the first quarter. As you can see here, we started in May. Initially, the team was really, unwilling to commit to deadlines because, they understood the situation on the ground. But as they started to see things improve, and as we started to identify additional root causes of issues, so, materials number one, but really, what was the root cause of materials not being ready? Well, some of the engineering wasn't done, which was a new root cause. So this enabled us to actually bring additional engineers in a targeted fashion to get ahead of some of the in-field engineering that needed to be done for some of the mechanical systems. We also identified that's very specific pieces of pipe spools. Happens to everyone on every one of their projects, I'm sure. We're coming in an out of sequence fashion. So we dispatched a team to South America to the facility that was fabricating the spools, identified the issue was really not spool fabrication. They also had a huge laydown yard, pipe spools everywhere. It was painting. And they only had one paint facility, one had broken down, and that was putting the whole process behind schedule. So we worked out a way to ship half of that volume to another paint facility, paint the spools in parallel, and actually have them arrive on site in a specific sequence, solving that problem. On to the next one. On to the next one being engineering in June, July, predecessor tasks. By August, the team was, really in sync regarding commitment reliability and what they were promising each other. What they now realized was possible based on what was known at the time for the project. as I said, root cause after root cause after root cause. As we move from the pipe situation, we now realize that as we got pipes on site, we still cannot hit our productivity targets. And as we continued to do our production control meetings, we identified the root cause of that is the inability for the predecessor activity, which was structural, putting up handrail and putting up structural platforms. That predecessor activity actually was what was holding up pipe spool installation. So again, move to the left, right? Move to the left. Predecessor activity, we actually identified the root cause of that problem being that we didn't have enough structural folks on site. So we were able to come up with a compensation package improvement that improved the retention of those folks on site. We actually applied that also to the pipe fitters because we knew that would potentially become an issue. And we applied the same package to the electrician because electricians were going to be next, and we knew that was going to be the next big hill to climb. So again, root cause identification, rapid mitigation to the extent possible of the root causes. Now we're getting into a situation where we were, if you remember, I introduced the thought of the two parallel paths, right? I call it almost the brute force method of in-field productivity enhancement and commitment reliability enhancement, and now the ability to plan and get ahead, right? As we are able to start planning and getting ahead, we now are able to look 5 or 10 steps into the future and identifying a very specific component installation on the critical path that actually was going to be the activity that either made or broke this project. And there were 100 of these components, very sizable, required a significant amount of rigging and crane action to get into place. And remember, just given the situation of the project, these cranes were used by other trades, was somewhat limited workspace as far as laydown and area. So there was a lot of work that was going to have to be coordinated to install these components at the same time as some of our other activities. By this point, pipe fitting and electrical work were happening at the same time as these components installation. So this ability to plan and get ahead allowed us to orchestrate the movement and installation of these components in off shifts, off days, weekends, and work around the other activities such that we were able to mitigate this risk before it even happened. So the installation, we were able to predict the number of components that had to be installed per day. We were able to practice their installation. We were able to measure how long the installation took, identify opportunities to improve it, bring that installation time down to a suitable level where we knew that we would make it for the project, and actually implement those changes and implement that schedule and implement that production mapping in such a way that we were able to get this work done in time to meet the objective. There's other things that have to happen. Yep, one more after this.
Couple of minutes.
Yep.
Okay, sure.
Other things have to happen. Folks often ask about the contract. The contract in this situation was not an impediment, but the makeup of the project team from the owner side and for the rest of the parties actually was an impediment to getting work done and getting the situation improved. As you can see on the left-hand side of this, very small project delivery organization that we expanded quite substantially, where we had folks assigned to each specific system area of construction. We looked ahead and knew the commissioning, ultimately was going to be the thing that got us to victory. So we assigned a commissioning lead to start working with the folks on the left in such a way that we could pre-commission, we could build commissioning process flow diagram. We could actually anticipate the things that were going to have to happen during commissioning. while there was still substantial work being done outside of the process, and anticipate any delays or overlaps with logistics, we assigned a materials coordinator for obvious reasons to make sure we knew where everything was and when it was coming in. And we assigned an engineering lead to improve the delivery of the outstanding engineering that I mentioned was an issue. So with that, I thought I would just put this slide up. I know it's time for questions. This might be a thought starter for folks. We often get the question, what changes day to day when you implement project production control on a project, either from the beginning or in a turnaround situation? I hope I gave you some examples of how things changed for the folks on the ground, but here's a little more structured summary of what changes for the folks that are actually working on the project when you implement project production control. And with that, thanks again for joining the session, and I look forward to your questions.
Excellent, Gene. Thank you so much. What an interesting story, because you have shared with us how you started in construction, but it seems you started moving backwards and going to supply and even engineering, right?
Exactly.
So I think that our audience really grasp that element of your story, because at the end of the day, you implemented this on a project that was up and running, right?
That's right.
But look, we have some questions for you, and the first question is, it says, Jim, any thoughts why the owner's project staff didn't seem to have the know-how or perhaps willingness to get into the detailed flow management activities on this project? and then this person in the audience follows with, is this common?
Roberto, you and I think have talked about this a lot, but I would say yes, it's common. I think many of our owner clients take a hands-off approach with their construction projects, and some for good reason. Some it's a simple project. It's something they've done 100 times before. It perhaps is a package plant of some type. But for most of the people in this audience, I don't think you have those types of projects. And this would have been that project. It would have been that project had the material been delivered on time. But as soon as things start getting out of whack, it's very hard for a team that's not used to issues occurring with construction to really identify root causes and actually stand up, raise their hand, and say, "Boy, this could get really bad, and we need to fix it now." And I think it's like standing at the switch when the train passes you by, right? You have that one opportunity to course correct, and if the train passes you before you flip the switch, you can get very far behind very quickly, right? And I think that's really the situation that happened here. The other thing I'll say is a lot of our clients say, "Hey, I signed a lump sum contract, and my contractor is going to take care of it."
Yeah.
That sometimes works.
Excellent. So look, we do have here a couple more questions that I think will be of interest to you and our audience. One question refers to, it says the following: did you discontinue the use of other processes or systems? It's like two questions in one, by the way. I repeat, did you discontinue the use of other processes and systems, or was PPM or production control implemented to close a specific gap in the way they were doing things? If so, what was that gap?
Yeah, that's a great question. I think so yes and no. I think we repurposed many of the meetings that had already been occurring. And if you go on any project, they have a daily meeting. Sometimes, given this one was somewhat in distress, they actually had twice daily meetings where they were trying to resolve issues, but nothing was really getting done, right? Because they didn't have the fact base to know
Right.
what to look for, right? So we repurposed those meetings to start talking about the facts that we were generating very quickly. You saw the very first chart, week 1, week 2. By week 2, we knew what problem number 1 was. By week 5, we knew what problem number 2 was, right? So we started repurposing those meetings to actually talk about those issues. And the meetings quickly became updates on mitigation strategies, because rather than bring the issues to the meeting and assign someone to go look at it and come back and report at it, report tomorrow, we actually set up teams to go resolve the issue and come back to me Friday and tell me what your mitigation plan is, right? So we just repurpose those meetings to actually focus on problem solving as opposed to reporting.
Excellent. So there's one more question here, and we need to wrap it up. And
Okay.
This question seems to be a bit, it's not necessarily related to this particular experience, but it's more about for you as a member of McKinsey, what have you seen in other places? The question is, I'm assuming McKinsey is doing PPM in other places. What are you learning overall?
Yeah, I think that's a great question. I've been involved now with PPI. I think I joined my first session 4 years ago, and I've had several opportunities to implement it. Most often in this type of situation, in a turnaround where we know it works. It's really the way that we do it. What's changed mostly for me now is when I walk to a project site, I look at different things than I used to look at. And when I talk to project professionals, and I would say this more broadly across McKinsey, we start with production thinking, and then try to back away with our clients. How far away are they from the optimum, which is fully a full-blown implementation of PPM, and use that actually as a way to predict potential issues that might occur with that project. So now we start with production thinking. I think that's the big change for me, and I would say for many of my colleagues is we start with that type of thinking as a way to assess what's possible, and then identify gaps from there.
Excellent, Gene. Thank you so much. We run out of time, although you got, by the way, several of the questions. It looked like you generated a lot of interest in our audience. So I want to, on behalf of PPI, thank you so much for joining us today. It was great to hear one more of your stories. I know, again, you have many of these, and very, very nice to see you. And thank you again for sharing the message. We need now, Jim, to transition to our next speaker. So
take care, Roberto.
Take care. All right. Our next speaker comes from Chevron Corporation. Please allow me to introduce Craig Evans. So I invite Craig to, there you go, Craig. We can see you. Can we hear you?
Hello, everyone.
There we go. Thank you. So, and one thing that is important to highlight is Chevron has been actively participating in previous PPI symposiums and events in general. Today, Craig will share with us new stories, how they have continued applying PPM in construction, obviously, because this session is about construction. However, he also brings a very short story about something that they have done in engineering, which he will take us through. A bit more about Craig Evans. He is currently a senior advisor of operations science at Chevron's capital project function. Craig has spent about 28 years in Chevron's capital projects organization and has held a variety of roles, key roles, including being responsible for the deployment of the Chevron's project management system across the portfolio of major capital projects in Europe, Eurasia, and Middle East. Craig has been directly involved in Chevron's implementation of project production management on the Future Growth Project, as well as other ones, especially in his new role as the Senior Advisor of Operations Science. Finally, Craig holds a Master of Business Administration from Deakin University in Australia, and he's joining us from London today. So one thing that I should say first, Craig, if you don't mind, Craig is very, very passionate, extremely passionate about excellence in project delivery, right? And I think that's something that is driving his focus on looking for new ways of doing things and looking for new ways of delivering projects, especially within the Chevron Corporation. So without further ado, Craig, welcome, and please proceed to share your screen.
Thanks, Roberto. Hopefully everyone can see.
We can see your screen, so I'm going to shut down my video, and it's over to you. Thanks.
Excellent. Thanks, everyone. And thanks, Roberto, for the introduction, and thanks, everyone, for joining me today. As you're aware, I've probably spoken a couple of times before at the symposium, previously mainly around EPC. Today, I'm going to take you a bit further into the journey that Chevron's going on with project production management as a whole. First of all, a little bit around why project production management, then how we're using different aspects of it on projects, and specifically I've got a case study around that, and then also some benefits and learnings, and then also I'll have a little bit of closing, and I'll leave some time for questions and answers. I always like to have an opening thought on these things, and 2020 has been one of those years that we'd like to forget, and we're starting to think about restarting work and getting back to normal. People say, well, maybe if we took a different view in the future and said, hey, what can we do? How can we do this differently? Let's not do it the same again. Let's take this opportunity to change something. Never waste a good crisis, I like to say as well. So just keep that in the back of your mind as we're having discussions over today. So why is Chevron implementing project production management? Well, you heard Gary earlier today talk about how as an industry and as a company we're not meeting expectations of our shareholders, and also just our general performance we put on ourselves. I would say if we could actually just meet cost and schedule, that would be an achievement in the current environment. Additionally, our competitors are not standing still. So they are becoming more competitive and more predictable. And we need to compete with other industries now for capital from shareholders as well in that space. So one other aspect of how we do projects is that we're in a resource business and we deplete reservoir fields. So we're in the business of continually doing capital projects to replenish what we produce each year. So if we don't do projects, we'll go out of business. If we don't do projects well, we'll definitely go out of business as well. Chevron's definitely been on a bit of a journey. So we started applying aspects of project production management, specifically project production control, back in about 2013, 2014 in China. And then we moved on to an onshore LNG project in Australia in 2015. And once we saw the benefit of those two projects, we specifically went out and started deploying project production control on more and more projects around the place. In 2017, we started looking at our projects more as production systems and planning around that versus just going into a project once it was up and running and controlling it. Specifically, like any project, and I think sort of Jim mentioned it before, production control has sometimes been implemented when a project is in triage. We wanted to try and get to the project before that point. So what we wanted to do is, look at the project or an element of a project as a production system. What allowed us to do this is probably we had improved our fluency in operations science over the years. If we'd gone and tried to do this straight away, I think we would have had a lot of resistance. and probably not really understood the results of what we were seeing as well. So an element of fluency also helped us understand this. So what does really modeling a production system, what a project production system look like? It's not a detailed schedule for sure. What you want to look at is the various steps in the work process that are going to occur in sequence. You notice I specifically left out the word time there. You don't want to add time to the production model initially. You want to map out the workflow, ensure people are in the right sequence. And then when you can start looking at how much throughput I can get through the system, then you can start adding time to a production system after that. Also, when you do a production model, you can identify a bottleneck, like you can see there in the top area in the high level map. And you can then detail that. You can then detail that out in a lot more with the project team. It's like, okay, where are my problems in there? The other thing as well is by starting at the higher level, you can also apply production modeling, I would say, when you're looking at different alternatives, such as am I going to modularize a project, and we'll talk about modularization in my case study, or am I going to stick build it? Those elements are going to have a significant impact to the overall production system of a project. You know, when do I need my engineering deliverables? What is my sequence of construction as well? Additionally, when you look at procurement, you know, where am I going to buy things from, and where am I going to transport those things around the world? And then we're able to identify, you know, capacity issues, bottlenecks, and elements like that throughout the production model. So specifically, what did we really go and look at? So we'd learned from a previous project, and I mentioned the onshore LNG project, that logistics is a critical element of a project and a project success. So what we wanted to look at here was, do our logistics systems have the required capacity? So we had a process, and I'll go through it in a bit detail, but it had ocean-going logistics, inland logistics, offloading and storage, and then stacking and final installation of a module. Now, our modules were large in scale, a couple thousand metric tons each, and I'll go into a little bit more detail in those in a moment. And the other part of this is, how do we actually eventually integrate our model with production control? So here is our overall logistics production system model. So what we did here, we sat down with both the logistics team, the team we had at the port for offloading and storage, and then also the stacking team. So our modules came in either 2 pieces or 3 pieces and had to be stacked on top of each other. They were fabricated in the Far East. So this is where the ocean-going logistics come in. And then you can see a whole bunch of barrels there. So that's a stock. So that's what is coming out of the fabrication yard for these modules. So then they were transported by ocean-going vessels to a transshipment port, which is where we say the inland logistics occurred. So here they were offloaded at the transshipment port. Depending on the weather window, they were loaded onto another smaller vessel, up an inland waterway system, across another sea, and then they reached an offloading port at that location. Then they were offloaded and stored and eventually transported around 40 kilometers to the stacking facility. Now, the stacking facility was a craned facility. We had 2 cranes. We had a ringer crane and a gantry crane. And what we wanted to understand was, where was the bottleneck in the system? Initially, a lot of the concern, I guess, and thought was that it was going to be in the logistics system and that, you know, construction would get it all done. And we'll see in a moment where the issue really was. Additionally, the logistics team did have modeling going on, but they were only modeling their processes. Once it really got to the offloading point, logistics had finished their job. It then became a construction issue. So we needed to link the entire system together. So what did we find out? So really what we ended up seeing was that the logistics was not really the issue, and it was quite well balanced. So the numbers on there is the utilization rate for each system. So ocean-going logistics was utilized at a 48% level, inland at 52%, and offloading and storage was at 49%. You might think that those numbers are a little low, but it really depends on what you're trying to achieve and trying to just get a flow through the system. We may have wanted to increase that a little bit. What we could have done is actually probably reduced an ocean-going vessel and reduced some of the inland logistics storage. Utilization rate would have gone up, and we could have saved some costs in that facility, those facilities, sorry. What we did see that our stacking facility was utilized over capacity, so about 40% over what it would, over 100%, and we don't want to utilize our facilities at 100% capacity. A good example there, and you may have heard it before, is if I'm on a freeway, I'm at 100% capacity, it means I'm pretty much not moving anywhere. So what we wanted to do was, let's look at our highest capacity. Now, what ends up happening the first time here is, we'll go down to the, so what happens here typically is that we'll say, okay, let's add more capacity to that. So the question was, will we add another crane? Now, adding another crane of this significance was going to be a large dollar item. Plus, we're only 40% over the capacity of 100, and maybe want to get down to 85%. So was there a way to do that without adding additional capacity? So we really wanted to look at, could we improve the workflows or the processes in the field to improve our throughput? So what we ended up looking at was, here's a little bit more detail of the module stacking process. So you can see it arrives on site and it sits in stock. We go through a pre-stacking process of where we might take off some sea fastenings, put some internal scaffolding in there. Then it moves to a stacking facility, so either a gantry crane or a ringer crane, and it's stacked at that location. And by stacking, it's then typically bolted together or welded together. Then it moves to post-stacking, where it will have some of the scaffolding removed, some other elements put into it. Then it's ready for transport, so it moves back into a stock. And then it moves from transport from the location, and then we set it on the module. So what we're looking at here is, can we actually improve this process? What we did by applying production, so let me go back a step. The model identified that the stacking facility was the bottleneck. So then we went and used production control to improve the throughput in this. By identifying standard work processes, by controlling the work and allocating the capacity through production control, we're able to improve the throughput of the stacking facility and not require the third crane in that element. We're also able to reduce variability in the system. One of the biggest impacts in this location is wind. As soon as we hit 11 meters a second, we cannot lift anymore. What we were able to do is identify, when the wind typically got to that point, and it was later in the day. So if we had arranged lifts in the morning and some of the more other manual work in the afternoon, we're able to improve the throughput of these facilities. The standard work processes also gave us some other insights as well, that a module actually was not being worked on up to 45% of the time. So as a component was going through the system, whether it be the two separate pieces of a module or the three separate pieces of a module, some of those components were not being touched 45% of the entire duration it took to get through the system. So what we would refer to as the cycle time. So there was opportunity to reduce the overall cycle time as well as we moved various components through the system.
5 minutes, correct.
Yep, thank you, Roberto. So what do we do to control capacity, inventory, and variability? So you heard Jim speak about this a little bit in his presentation just then. So very much developing standard work processes. So even though each module was bespoke and different, the process for pre-stack, stacking, post-stack, transport and installation was similar in each case. So we would use standard processes. Then what we would do is we'd use those standard processes to rapidly develop a production schedule. So we could explode our schedule into daily tasks very quickly with the project team. Typically, you'd see us have a production scheduling meeting once a week, and that may go for about somewhere between 1 to 2 hours most. And that was really planning out the next 3 weeks worth of work. Then within the daily production planning meeting, we would allocate capacity. and we were allocating capacity across various different contractors on location. So we had survey contractors, we had transportation contractors, we had the lifting contractor, we also had the mechanical integration contractor, and there was 2 of those on site. So we were actually allocating capacity across 4 or 5 different contractors on a daily basis. Additionally, once we had some analytics and we had some runtime, we were able to look at the analytics coming out of our CVX PM tool, so Chevron Production Manager tool, and we could use those analytics to help drive performance. Like I said about, that we had a lot of time where components weren't being worked on. Through the standard processes, we could identify the lag time. So at the time a component, one task was completed to the time the next task started, we're able to identify those lag times. So results and learnings. So overall, we reduced the schedule duration for the stacking for a particular year by 3 months. So that was roughly a 30-month saving in duration there, which meant either those workers could go on and do other work, or we could demobilize early because we're a weather window affected stacking facility. There was no requirement for the 3rd crane. So in this environment, it was remote. A 3rd crane would have cost around $50 million around that. So we definitely did see, so that was really cost avoidance in that instance there, and also say, some cost savings through the 3 months around that. Learnings. So adding capacity is not the only solution. That was one of the big elements that we were able to educate our team on here, that they could actually get better throughput the system by actually optimizing workflows and not just adding capacity. The other one I talked about, the lags. So construction, a lot of the time focuses on the capacity waiting for work. So the people waiting for the work. Equally important is the work waiting for the capacity. So when could the work move to the next station there? And then additionally, by reducing the WIP or the through in pre-stacking, we weren't getting a big bottleneck in that space. We actually ended up requiring less capacity through there. So one of the things coming out of this is really, we could model with the production system optimization process. It was informing us where our bottlenecks were, and then we could control and drive the performance with production control. That was the module case study. I wanted to just spend a quick 1 minute, if I can, Roberto, on a smaller scale application, in engineering. So this is looking at piping isometric drawings, or it could be applied to any kind of drawing. So this work was going to be completed over roughly a 6-month process. So we mapped out the production system. In this instance, the capacity or the resources of people. So we had a predefined number of people that the contractor told us, this is how many designers I'm going to have, and this is how many engineers I'm going to have. Out of that, we're able to identify that the bottleneck was going to be designers, not the engineers. So you'll see that the blue line, hopefully it's showing as blue, or the top line on the chart is showing what the contractor forecast production was of isometric drawings, or let's just assume drawings. The line at the bottom, or the orange line, was what the model told us was going to occur with the allocated capacity. So they wanted to finish by the end of, I think it's October. We were predicting they would finish by the end of December, based on the capacity they'd allocated. What started happening, you can see the black line was starting to track the actual. They didn't add any capacity. They moved forward with what they had planned to use, and they were close to or tracking the model that we had. Now, here we didn't apply production control. We were just monitoring the work they were doing in this instance. And then you can see they added additional capacity, and then you can see it then kicked up and ended up finishing, pretty much between the month of October and finishing around the end of November, so 1 month later than expected. What I just want to show here is that it doesn't have to be a large piece of work to model a production system. You can look at a smaller piece of work, a sub-element of work within both engineering, you could do procurement, or construction elements, and then control it with PPC, and you'll see the results come out of that element. So with that, just closing, so I'd like to thank all of you today for listening to me again for the 3rd year running, if you've been here the last 3 years. Our journey continues. I've only been in this new role since October, so I've got a lot going on next year in how we continue to move and integrate operations science into our capital projects organisation. So with that, Roberto, back to you.
Thank you, Craig. Really very interesting story. I think for, you keep teaching us how an organization like Chevron, which is a very large organization, is approaching, management of your projects, management of your capital. And I think you mentioned the term production systems not only once, but multiple times. I think that is part of the key, and how you have looked at modeling production systems, how now you're looking at controlling production systems. The first question I see here, it's about that actually. And this person in the audience is asking us the following. Well, actually, two questions combined in one. So let me see if I can do a good job here for you. The first question is, are those processes you were showing us the schedules? That's the first element of the question. The second one is, how do you identify production systems in projects? How did you, Chevron, do that?
Okay. So the processes, as I sort of mentioned at the beginning, they're not schedules. So what you're doing is you're getting down with the people who are going to execute the work, whether it's somebody in engineering or whether it's somebody in procurement or construction, and asking them, just tell me the steps that you're going to go through to execute the work. Don't give me a time, don't give me duration, just tell me the steps, tell me the interface points you have with that process. So essentially that's where we start. Then we start looking at what's the throughput we can get through the system. So whether that's people or cranes or how much work, then that's going to define when you're going to be finished at the end of the day. So it's not a schedule where we typically look at something and we'll put a bunch of bars on there and say this is how long it's going to take us to get there. We're very much defining the duration based on the throughput of the system. One thing where Chevron is moving to, this was decided this year, is we're going to start out with developing workflows before we develop P6 schedules. So the first thing you go on a piece of paper is going to be a workflow, not the actual duration of the schedule. So that's another element there. The second one, I would almost argue that every project is a production system. You may only produce something once, you may produce something hundreds of times, but it still has an element of being a production system and will behave according to the laws of operations science. So therefore, identifying them, I guess, is not hard. Maybe the part is identifying the ones you want to go work on is probably the more important element there. You can see how I showed that we identified there was four mini production systems linked together to deliver a module. We focused on the one that was critical. There wasn't a lot of benefit to us to go and focus on the other three that were delivering what they should have done. We could have actually maybe, on those improved the utilization of them, would have been the opportunity there, so cost saving, but we're already into the process and it had already been set up.
Thank you, Craig. So we do have a couple more questions. So let me take you through this, the next one. This is about current practices. It says, what current project practices have you seen that are the most difficult to overcome when adopting PPM, and why you think it is that way?
This is always an interesting one. I'm probably going to talk about this a little bit as well. I'm on the panel at the end of this project as well, at the end of this event today, sorry. It's preconceived ideas, I think, that projects don't act as production systems. I think I made a statement last year or the year before that we have flat earthers within projects that will believe in single point load of gravity and construction, concrete and things like that, but don't believe that operations science applies to them in projects. So one of the hardest barriers has just been to get people thinking in an operations science mindset. Some of the other things is what we sometimes see as best practices aren't necessarily best practices straight away. There's potentially a lack of empirical evidence to support those. Versus when you've got something like a Little's Law, you've got science behind something as well. So I think changing the mindset in the industry that we can take what, say, manufacturing have done, or we can take operations science and apply it to our projects is one of the hardest things to overcome.
Excellent, thank you. We do have a question that I believe is related to what you just mentioned, and it's about work in process or WIP. The question says, how do you identify WIP in construction processes, and what is the impact on deadlines?
Okay. So we identified WIP a couple of different ways on the project. The easiest way is to actually walk around a construction site, and you tend to see a lot of it. However, through the processes, what you can see is within the system there, so within that model that I showed you, you would have ended up with a whole bunch of WIP pretty much sitting in storage, waiting on the stacking facility to move through it. We would have had a whole bunch of modules sitting on site, waiting to get through that system. So that's where the WIP was going to build up for us. We use various different tools within Chevron Production Manager. We use some dashboards. So when you have a standard work process, you can see where the bottleneck is and where the WIP is sitting. One thing I also want to mention is that it's not zero WIP. So it's not zero work in process. You have to have the right amount of work in process to ensure that the throughput is optimal as well, and you can get good cycle times as well. So it's a little bit like, sometimes people sort of say just in time, and we're not. No, it's not just in time. We need the right level of inventory or the right level of WIP in the system to ensure that the flow of work is continuous.
Excellent. Thank you so much, Craig. And one thing that I would like, this is not a question, but perhaps a comment, because you presented something along the lines of one of the outputs of your production system model being 140, I think was the number, capacity utilization on an element of the production system, right? And so what it might be important to re-emphasize is that the idea of a bottleneck is really an operation that has the highest capacity utilization, right? And so people typically refer, oh, the bottleneck is the slowest step in the process. Well, the question is, why is it the lowest step in the process? Is because typically is the one that has the highest, over 100 or close to 100 capacity utilization, right? And so as you said, operation science allow us to look at that. So I just wanted to highlight that element of your messages. So with that being said, once again, Craig, thank you so much for your openness, for coming here and sharing what you are doing, what you're thinking about, the opportunities, and how Chevron is making it happen. So always good to be inspired by people like you.
Excellent. Thanks everyone for attending the symposium.
Thank you so much. So we're now going to transition to our last speaker. It is with great pleasure that I would like to introduce Adrian Oltanu from Microsoft Corporation. So Adrian, if you don't mind to share your video, and okay, great. And you probably can hear me and we can hear you. Testing.
Yes, I can. And I'm hoping that you can hear me as well.
We can hear you very well. So welcome to the symposium, and thank you very much for being with us. So Adrian is going to share with us how Microsoft is applying production management, project production management processes, principles, methodologies to effectively synchronize the supply of data center equipment with obviously a required demand from data center construction sites. Before I allow Adrian to take us through that story, let me say a few things about him. And I think, Adrian, people need to understand who you are, and you have a significant amount of experience. So let me share with them a bit of your background. Adrian is currently the director of data center lease strategy for Microsoft. Together with his colleagues at Microsoft, he has been directly involved in the adoption of PPM for supply optimization. Prior to Microsoft, he was a senior manager, portfolio management advisory for Ernst & Young, and also he held several roles at Franco Retail, including becoming the CEO and running the organization. As you can see, Adrian brings a breadth of experience, and we're lucky to have him here with us today. Adrian will handle his presentation a little bit different than what you have seen. He will verbally describe what Microsoft is doing and the journey they have gone through. So thanks again for being with us, Adrian, and this is over to you.
Yeah, thank you for the introduction, and thank you for having me here today. It's been a very interesting day listening to what has been discussed prior to now, and I wouldn't like to repeat what has been said. Obviously, we went through a similar journey. We have faced similar challenges, and I would like to maybe come up with a different flavor and discuss more a little bit about the challenges that we've seen in adapting, and the pressure on our organization to adapt, and the pressure on our partners in understanding that we're not trying to convert them to a different religion, but we are trying to implement best practices and do the right thing so that we can ultimately achieve together, and this is a very important element, together, better results. I'm sharing my screen right now, and you should be able to see it's a nice image of our global network of data centers. And before diving into what we've seen in our journey, started more than 2 years ago, I believe actually 3 years ago, in implementing a production system. I'll share a few things about what we do. So at Microsoft, the software, obviously, it's one of the products very well known that we are delivering to our customers. The hardware, it's another one, the Surface devices and Xbox and other hardware devices. But we believe that the data center, it's probably a third product that we are building that is powering the entire ecosystem of physical products, and then software that is powering them. We have today close to 300 data centers globally, and we are growing at a rapid rate. Our capital investment, it's in the range of $20 billion a year in building and leasing data center capacity from external providers. When we started our the implementation of production system journey, probably 3 years ago, we started as has been mentioned, with rationalizing the procurement of equipment, of long lead equipment that is being deployed in our own data centers. We complemented that initial work stream about a year ago with expanding the program to managing the procurement of leased data centers. So the first part was equipment that goes into the data centers that we are building. The second one is the capacity, the data center capacity that we are procuring from external providers. And there are lots of learnings that I would like to share with you. First, the challenges, why we thought about doing it. We started with very simple things that have been mentioned earlier today. We did not know exactly how many projects we have in flight. As simple as it might sound, this is a problem that probably lots of organizations are facing. So we wanted to know with higher level of confidence how many projects are in flight at any given time. How long does it take for the projects to be completed? We had a pretty fair or reasonable understanding of assumption that it's taking longer than it should take and longer than what we were expecting. So the third element in our journey has been to set up the goals for how long it should take to either procure equipment, for the equipment to be manufactured, ultimately for the procurement to be shipped and installed and be part of the final product, which is the data center. So these were some of the say common data center common challenges, and it took us probably 9 months to have good visibility into the body of work, and to start thinking about the fact that we need to standardize our processes so that the next delivery will be similar to the previous one, and not every project will be unique in itself. We ended up having more than 100 standard processes that we created in the system. Each of them mapped to different providers of equipment and different equipment types, from let's say an air handling unit or a generator or any other mechanical or electrical types of equipment that we are using. And the way we came to have those standard processes has been by visiting the manufacturing sites of our providers and working together with them on defining the standard process, the standard steps that they are taking in order to procure their components for the equipment that they are producing for us, and then the actual manufacturing, to identify the idle time between steps, and to identify the buffer areas that they created, that we created, and how we can optimize. Having as ultimate goal or ultimate goals, three main KPIs. On one hand, we wanted to reduce the cycle time, the amount of time needed from between placing the order to finally having the equipment delivered. We started from a very high number initially. We refined it to somewhere in the, depending on the equipment, 6 to 9 months as cycle time, and we set us a goal to reduce to cut that in half, to reduce it by 50%. And we managed to achieve that probably another year later. So first 9 months were dedicated to implementing the program, then the next 12 months to start driving the efficiency. The second KPI, in addition to reducing cycle time, has been to eliminate the unplanned, we call it unplanned buffer. We noticed that, just to give you a few examples, we had equipment being shipped to the construction site 2 months prior to it being needed at the construction site. In the case of some large equipment, not even having the concrete pad for the equipment to be positioned in that final place. So when looking at those items, we understood that it also what we call unplanned buffer, and it was an opportunity to eliminate that unplanned buffer, and having as a consequence a reduction in the overall cycle time. And the third KPI for us has been the on-time delivery performance. When we looked at how many pieces of equipment and then how many projects are being delivered on time, we saw that we are somewhere below 70%, which is not such a bad number, but it's not where we wanted it to be at 100% on-time delivery. So almost 3 years now into the project, we are at consistently above 90%, very close to 95% on-time delivery. So from 70 to 95, it's a significant achievement, because we also managed to reduce the cycle time almost in half during this entire journey. So this has been our the challenges that we tackled and the goals that we set for our first project that leverage production system principles, manufacturing of equipment, delivering of equipment to construction sites, and the installation of those pieces of equipment. Now, what we've learned, and this should not come as a surprise, is variability. It's very important, and we have the typical sources of variability, but we realized again, not as a surprise necessarily, but we realized again that the human factor is bringing a lot of variability. The resistance to change, it's a factor of variability that cannot be ignored. And let me double down on this one for a moment. As a good best practice, we started having weekly production what we are calling production control meetings, including our providers, the manufacturers of equipment, including several subject matter experts within our organization. At first, these meetings were happening, in a way to check the box. Then they morphed from checking the box to be a little bit more proactive. But ultimately, they had to, and we're happy that they ended up being something that is happening, and it comes naturally to the subject matter expert. They are doing it because this is helping their job, and it helps them be more efficient and more agile. So this has been a very interesting learning for us, and we are reflecting on this, how we managed to take the organization from being extremely reactive for doing it because they've been asked to actually driving the conversations and driving the meetings and using it in their day-to-day business, so that the goals that I mentioned earlier are a result of the normal regular activity, and they are not forced in a way to our individuals. So this has been a very interesting journey. Another one, data-driven decisions are oftentimes they have I wouldn't say consequences, but they have byproducts that you might not be anticipating. So having visibility into the body of work, having the ability to see how long it takes for every step that you are defining, having the ability to see where there is waste and where there are opportunities to reduce that waste, has an element of for a certain number of individuals, has an element of a reflection of personal performance that cannot be ignored. And what I'm trying to say here is the challenge for us has been to remove the personal element and the reflection of a personal delivery from the conversation, and to focus on process and the process improvement, so that our team members will be motivated, incentivized, and comfortable in truly embracing the red and the yellow, and not trying to call out that everything goes well when everything is not going well. So data-driven decisions and access to information and availability of the analytics coming from the production system, this has been truly beneficial, and something that allowed us to progress and to generate the results that I mentioned earlier. I'm going to pause here for a moment to see. I'm not sure if I can see if there are any questions or.
Yeah. So
Roberto, tell me how we are doing.
Yeah, we're doing pretty well. We have about 8 minutes, Adrian. So
okay.
I would like to propose we do a couple of things. I have been listening very carefully to what you have been saying, and the different things that really took my attention. So please allow me to perhaps very briefly summarize things that really took my personal attention, as I said. So one thing you mentioned is that this is not something you have started 2 months ago. It's about a 3-year program on how you could actually optimize your supply chain for data center equipment. Number one. Number two, obviously the journey has been an interesting one. Some people in resistance and some few things. You told us that you have been able to reduce the supply lead times or cycle times by 50%, I think, if I pick up the number correctly, as well as move from 70% to about 90 to 95% on your supply reliability, if you will, right? Arriving at the right time, right? And the other thing that you mentioned, a couple more things that you mentioned to us on top of my head is one, that this is not something you are doing alone, meaning that you are working with your suppliers, right? These are companies that are located in different places. They are joining different sessions, different working sessions. Production control, I think, is the term you used, where they will participate on decisions associated with the production systems, right? And the other thing that you mentioned is that because you are looking at data-driven decisions, and you enable more visibility, not necessarily everybody likes that, because you are trying to, get a sense of reality, and sometimes that reality is not what people like, correct? Did we
That's
get it
correct.
right?
Absolutely, yes.
Excellent. So we are getting actually some questions here for you. So let's go through probably 3 questions. So why do you think, let me see here, why do you think your suppliers might be extending lead times? Okay, so this is, do you think your suppliers are extending lead times purposely?
At first, yes, most of them were. And it's a very simple explanation. I mean, in some cases, they did not have a standard process. They were kind of guesstimating how long it might take. So they are quoting in order to over deliver. They were quoting longer lead times, not having an optimized flow into their process. And what's very interesting is you also mentioned earlier, Roberto, what I called out, that we couldn't do it alone without our suppliers, which is absolutely true. But also we cannot be successful without them. And what's interesting is that it's a tag along situation here. We are, by implementing a production system within our organization, we are driving the same discipline with some of our providers that are recognizing in return the benefit of doing it. And they appreciate the fact that we are helping them be better. And it spans not only for the production system, it spans also for the health and safety, for instance, protocols that they are implementing and they are using, and all of the other best practices that we are at first pushing to them, and later on becomes second nature to them, and it helps us be better in return as well. So yes, yeah, this has been what we observed.
Excellent. So we do have, thank you, Adrian. There was a couple more questions for you. This one is an interesting one. So it says, reductions in cycle time by 50% and achieving 95% on time delivery are very good results. How much is because of PPM, or will have occurred simply because of repeat processes if you hadn't used PPM?
So it's a good question, and hard to tell, or how to separate how much is purely PPM and how much is not. What I would say, standardizing the process, we couldn't have done it without standardizing the process. Can you standardize the process without PPM? Probably yes. We couldn't have done it without having the weekly production control meetings. We couldn't have done it without all the dashboards. We couldn't have done it for a number of ingredients that are part of PPM. So I would say each component individually probably can be done outside of PPM, but the fact that all of them are part of PPM allowed us to be successful. So I'm more inclined to say you can piecemeal it, but you have to look at the entire pie and implement it in order to be successful.
Interesting. So yeah, so you're selling because you have to look at a production system perspective, right? Rather than chunking things. Okay, good. There's more question here. One more question for you. Does Microsoft have large storage at each of your data centers, or do you use hubs and or have your vendors hold the materials?
Yeah, there are 2 types of items here. We have the very large equipment like air handling units or generators that, in a way, the storing place for them is the ultimate place where they are going to be installed. So we do not have a storage for them. We do not have a temporary storage before being finally installed. The whole objective of this lean manufacturing is for the equipment to be manufactured, shipped to our site, and positioned into the final place where they are going to be installed. We do have small storage for a small area for storing the smaller equipment that needs to be tested prior to being installed. So that's happening at our site. Now, when it comes to manufacturers, we do have some agreements with them to have a buffer inventory in place for those items that are in high volume, high quantity, and we know that we can shift the supply to different sites. They're not necessarily tied to one particular site. So it's a combination of all of them, but I would say probably 50% of the not volume, 50% of the critical items are being shipped directly, and the other half stored in some temporary locations to be tested.
Excellent. So we have one more for you, and this is the last one. We need to move into the next session. So there's a person in the audience that is asking the following: approximately how many suppliers were involved or are involved in your PPM program? How did you position what you wanted them to do so they get involved, so they join the effort?
We have close to 50 right now into the process, and I'll be very blunt. They did it at first just because we are probably Microsoft and we are an important customer, but that was not working. I mean, checking the box and doing it just because we asked for it, it couldn't have been. It has to be a win-win situation in order for it to be successful and for us to truly generate the results. So that first year into our journey was dedicated to explaining the benefit to our providers, for them when they are attending the weekly production meetings, to bring the latest intelligence into where they are in the process, and to have that type of critical thinking to perform root cause analysis when there are delays or deviations from the plan, to go back to their internal process and tweak it and adjust it because that's the right thing to do, not because that is what Microsoft is asking them to do. So it's been a journey, and it's different with each of them. Whenever you have a smaller provider, they are obviously more agile and adjusting much faster. When you have large global manufacturers, it's a little bit different. Also, we have a global footprint, so when dealing with different cultures in Asia or parts of Europe or North America, the appetite for embracing change is different. So lots of learnings here on. I'll go back to that change management and the human factor, and the certain cultural norms when doing business in India, let's say, or in other parts of Asia, and knowing how to decode a yes or okay in the United States has a different meaning in Asia, or a different meaning in Europe.
Excellent. Yeah, and something you mentioned that I would like to highlight, as I did initially with all the things you shared with us, is the fact that you guys went to, I think that's what you said, please correct me if I'm wrong, you went and visited the suppliers, and that was the basis of an initial idea and on what you have called the standard processes, right? Understand how do they produce, what do they do, if there's some variability kicking in, and handling with better assessing the processes. Correct?
That's correct.
Yeah. So we, in relation to that, we have one more question, and this is, I believe, important. So let me finish with this. So the question is Microsoft using PPM data, cycle time, throughput, performance per supplier as the means to decide if you should continue or not working with them?
The answer is yes. But I would say I would nuance it a little bit. We are definitely use PPM data to assess the performance of our providers so that we can have a performance improvement program. I wouldn't say if we are deciding to continue or to stop working with them, but we are analyzing heavily, and we are sharing with our providers to identify opportunities for improvement. Because again, together we are stronger. And if we are to look at and rule out providers when they are not performing at their best, probably it will be a matter of time until we'll be alone on this world and have no providers to work with. So
Yeah.
it's a journey, and we have to improve, constantly improve, and that's how we are mainly using the data.
Excellent, excellent. I like that answer. Well, Adrian, so look, on behalf of PPI and our audience today, I just want to thank you so much for joining us and sharing such a fantastic journey that Microsoft has started and continues through. And so really appreciate all the details that you brought to the table today. Again, it's a great story of proven success. Thank you so much.
Thank you as well.
Thank you. So it is about 3:05 Central Time. This particular session on PPM applications is going to conclude in about 25 minutes. And because of that, before I move to the next, we're going to give the control to Ed Pound, Executive Director of the Project Production Institute. I really want to thank Hess Corporation, Tripatra, McKinsey & Company, A.G. Kunz, Tengiz Chevron, and Microsoft for their participations. What an amazing set of stories. Every single one of them different, with different applications, different challenges, some of them in design and engineering, construction, and that give you, I hope, for those of you that are on the other side of the screen, a good sense of what is possible and what people are doing now. Because I don't think we are talking about investing in research or things that are not even doable. I think these are industry professionals that are showing us how things are being done as we speak. Okay. So really, really much appreciated. And with that being said, I leave you with Ed Pound already on video, and he will actually summarize a few things for us. Over to you, Ed, and thank you so much.
All right, thanks, Roberto. Yes, absolutely wonderful presentations by everybody. As a matter of fact, there's so much information, so much processing going on in my brain. I overheated, had to take my jacket off. So relaxed, enjoying all the feedback. Hope everybody else is also. What I'm going to do really quickly here, what I'm going to get to, talk about the ending first, is I want to get what your takeaways are. So people have been listening to this. This particular track is for folks who are not so familiar with PPM. So when we get to the end of this, I'm going to do some review. And then when we get to the end, we want to get your input on takeaways. So without further ado, let's go through that. So the first thing to do is go through what people talked about, and you'll see why I'm going to do that when I'm through with that. But if I look at what Pathman talked about, and I'm picking out one slide from each presentation. So Pathman was looking at and identified how it was really important to look at variability, and looking at variability and capturing the reasons for variability really helped them move from where they were to where they wanted to go. Now, there's a lot of other things involved. I'm just picking out one particular concept from each slide. Dira talked about production system optimization and looking at inventory and this idea, and I think actually Gary mentioned that early on, this idea of like, yes, you can ship everything out to the site and you can have it all lying around so you're looking at it instead of looking for it. But what you've also done is you've tied up a lot of cash, and there's a way to be able to optimize how much inventory that you do need. And I think Craig mentioned that actually. The point is not zero inventory. That's a fantasy. You need some amount of work in process, some inventory in your process, and understanding what the right amount is, it's what's key. And that's what you get from a project production management understanding. Jan talked about production system optimization. And this is really interesting because these were really big facilities, specialized facilities. This is not your standard pipe spools that you're making. And doing the production system optimization and the modeling ahead of time enabled them to really help the client understand that they could save 5 months in the schedule, and also work which was counterintuitive, it would be faster if they worked with less work in process. And so that was a big takeaway and really helped them and got a lot of good insight. It's a new way to think. We'll talk about that in a second, but really helpful for them. Alex was an amazing description of how data centers are going up, and then Adrian kind of finished with a discussion on the same talk. But yeah, his thing was, look, we're not building things in place. It's not sort of the craft approach. What we're trying to get with data centers, if you remember, he said design in one day, okay? And so that's really now looking at all those levers that we talked about earlier and applying those in the PPM framework to get to that, because as you saw from Adrian's map, that's a massive scale of facilities that they're maintaining throughout the world. And that's what makes our internet go. So a very interesting application of project production management. They're also really pulling all of those levers together to get to that design in one day. Dorina and Ludwig talked about CAPE applications. This is a favorite of mine because I actually was standing right there by those guys who were lifting those pieces in place. And they were talking about doing the work in practice, basically modeling it and doing it ahead of time, right? And so you understand that, oh, wait a minute, I'm doing 93 of these expansion loops. That sounds like a production process to me. I mean, it's not a permanent production process. I'm not making automobiles, 100,000 a year for the next 20 years or whatever. But 93 over a couple of years or whatever the time frame is, that's a production process. And maybe I should look at that ahead of time, look at the design, and look at doing a first run study, the installation ahead of time to learn about that and learn about my production system before I do a full scale rollout. And so a lot of good results from that, cycle time reductions, big savings on labor. And then Jim talked about working a project and how to get one that's out of control in control. As he mentioned, this is one of those projects that it's not like they haven't done this before, but this one in particular got out of control. And so needing to come in and work with people, and it was kind of a sequential process. First thing to do is understand what the problems are. What is my production system? What are the causes of variability? Because if you look at this commit reliability from an operations science standpoint, that's the same as demand variability. And demand variability causes an increased requirement for resources is the simplest way to put it without going too far down the rabbit hole. The point being that more variability requires more resources to manage. And by putting a project production structure on top of this and looking at it, you don't necessarily, you get control of that and you reduce your own self-induced variability. I mean, there's good variability. I mean, the fact that you're building different structures for different owners, well, that's variability. You don't build the same thing for everybody all the time. That can be good variability, but you have bad self-induced variability where people don't understand what's going on. They don't know where the material is, that sort of thing. And that variability, whether it's good or bad, sucks up resources. And being able to work on commit reliability essentially is reducing your variability in your production system and enabling you to perform better with fewer resources. And Craig talked about those huge modules that they moved from Korea or Italy or wherever the fabrication location was to the installation site. And being able to understand, well, wait a minute, I don't need to spend an extra, $50 million for an extra crane. If I just understand where my constraint is and work on the constraint, which is a basic operation science principle, I can get the same or improved throughput, maybe even with minimal investment of resources. You won't find every time that I shouldn't invest in resources, but a lot of times what people will do is without an operation science view, they'll say, oh, I got to cut costs, cut costs, cut costs. Well, sometimes the idea is to invest a little bit more in a resource, for an extra crew to save you a much bigger cost later on down the road, like for instance, a crane. And then, of course, as we mentioned, the Microsoft Cloud operating at scale, that's a huge scale. That's a worldwide scale. And they were there, you can see, just trying to coordinate this magnitude of installation, being able to reduce cycle times by 50% and increase on-time delivery to 95%. Now, wait, increase on-time delivery by 95%. What's that similar to what we just talked about? That's the same as commit reliability. So if your suppliers are more reliable, it's the same as your crews on site being more reliable. And what you're doing is you're reducing variability, which requires less resources to accomplish the same thing. Okay, so great insights. Really love those. It's a different way to think, particularly if you're not if you're not familiar with PPM. And so we come back to, oh, wait a minute. I don't think anybody really talked about the iron triangle. You know, there was some discussion about productivity, but what you found was you increase productivity not by trying to keep everybody busy all the time, but by understanding your project production systems and using those as effectively as possible. And I think, as Jim mentioned, it's kind of a stepwise process. You know, as you push further and further into where the problems are, the causes of variability, you get productivity increases, right? And so it's just a different way of looking at things. You know, obviously you're going to have scope and quality. That's what you're going to have, a schedule, and you're going to have resources, right? But what and when by who is not going to get you the results that you want. And that's a really important takeaway. We're not saying you won't have those. You're still going to have a schedule. As Craig mentioned, you know, what they said now is they're going to understand their production systems, and then they're going to create a schedule, which is really the way to go about it. It's not saying that you're not going to have a schedule, but just looking at a schedule is not going to give you, it's a prescriptive model, basically. It says what should happen. It's not going to tell you what will happen. And so here we come to the sort of a central concept. If I look at the schedule, that's giving me dates and progress. That, you know, essentially is telling me what my demand is. But what really determines, that's what should happen. What really determines what will happen and what can happen are your production systems. And it's a great way to think about this. Todd Zabel said just the other day, it's basically like you're on, you know, we've crossed the river. If you're looking at a project production management approach to capital project delivery, basically you're on a different viewpoint. You're on the other side of the river, and you still, if you're looking at it just from the classic project controls schedule control approach, you know, you're just in a different world. And so what we want to do, and hopefully we did for you today, was at least to kind of give you an idea that, hey, maybe there is a different way to look at things, because it's guaranteed that your project, your production systems in your project will tell you what can and will happen. And that's what's key, really, to managing and delivering projects successfully. Also discussed was, I think Gary talked about this early, but the tendency for project managers, and you know, he said this when he was evaluating how he had designed the Chevron project system, is to just load up different steps with inventory. And the drive for that is people are optimizing locally, and they think, oh, if I have enough inventory, I can just really keep busy and keep everybody busy. And if everybody's busy, things will get done more quickly, and then I'll be more productive and make more money. But that's not the way the world works. That's more kind of an accounting model. You know, get 100% utilization, and I do more, and so the resources I'm using are more productive. But what really happens in terms of the project production system behavior is that work in process or inventory is essentially time. Okay, and so the more inventory you have, the longer it's going to take to get things done on average. More time means more cost. More time and more cost means lower ROI. So that's an insight that you get from looking at projects as a collection of production systems. And then, of course, we didn't really go into this too much, but the point is there is science at the heart of this, right? Observing nature. These are descriptive models of the way your projects will behave. And, you know, there's a relationship between work in process and cycle time, work in process and throughput. And then your batch size. Now, batch size, how does that fit with projects? Well, when I'm talking about work phase planning and what the size of my work package is going to be, that's a batch size. And what you see is the larger the batch size is, just intuitively looking at this, the longer my cycle times. If I'm doing agile and I'm trying to determine, my product backlog and what's going to be the work duration for my sprint, oh, well, that's actually a batch size decision. The point being that those are all structures that people work in. If you don't understand the science, the underlying science behind that, you might end up tripping over yourselves with all the best intentions. And so project production management is based on the operations science, these fundamental concepts that describe behaviors of these systems between inventory and capacity and response time and variability. And understanding that is the key to understanding how your project production systems work. So as mentioned, what's really going on is, it's not just about what and when and who, it's about your product and your process design and how those work together. Alex, when he was talking about data center design in a day, really was taking that to the extreme where, that forces you, saying that's your goal, really forces you to look at all 5 of these levers together, right? But sometimes what happens is you walk into a project, and some of you might be on them now, where look, the product's already designed, the process is in place, and I'm still behind. I can't change those 2 levers. What am I going to do? Well, you still have a couple levers that you can work with. There's capacity and inventory and variability. If it's a situation where we've seen it before, where, oh, well, guess what? We're doing 2,000 pipe spools and they're already on site. Okay, well, that takes that lever out. And so now I have 2 left. The point is, this is a really simple, straightforward, and authentic model in that it reflects actual options to what you can do to get your projects under control. The 5 levers: product design, process design, capacity, inventory, and variability. And so understanding your projects as a production system will lead you to repeatable and predictable control of your projects. And of course, that's what drives the PPM framework. And Gary talked about this earlier, so I won't rehash it. But you have operations science, and then you have actually 3 separate segments of project production management, which we've all touched on today. Production system optimization, that was what Jan talked about, computer-aided production engineering. Darina and Ludwig talked about that, and project production control. I know Jim talked about that. This was all mixed throughout. It's not like you're just going to do one. You might walk in and you might do only one. You might do some combination of them. But if you're looking at projects and production systems, these are the approaches that you would take to understand how to control that system to get the results you're looking for. So in review, rates drive dates, right? The rates of your project production system. Dynamic projects require rapid replanning, and people doing the work, and Gary emphasized this morning, do the real planning. As he said, he walks out there on the site and they say, how's your schedule look? And they say, oh, you mean that thing on the wall that we never pay attention to? The people doing the work need to be doing the real planning, and it's all based on science. Okay. So that was a really quick run through. What we'd like to do now is get your feedback, get your takeaways. And so what I've done here is I put basically the poll. Okay, so hopefully you've been with us before, but if not, this is a QR code that you can scan with your phone. You should also have in your chat window this link, which you can click on. And what I'd like for you to do, and I'm just going to leave it here for a few minutes because it takes a few minutes for people to go through this. Describe your takeaways from today's sessions. That means all the sessions on how leading companies implement and benefit from PPM. So not looking for a long, a lot of prose, just 1 or 2 words or 3 words per takeaway. And then what we'll do is we'll accumulate those results and see what we come up with. All right, so I'm going to leave it there for a second or for a minute or 2, and then we'll see what the results show. While I'm doing that, Roberto, did I miss anything there?
I think you know, you highlighted all the main elements. I think it's important to really understand how production systems behave, and there's a method to the madness, right? There's a framework. This is not about what you think. This is not about what I think. This is about how a production system behaves, and it's beyond someone's opinion. It gets down to a specific behavior, right? And we're not going to understand that behavior by looking at schedules. Schedules these days are being used for other purposes. And I think what we are seeing, and all the stories that the experienced speakers brought to us today are a proven case for, you know, that the idea behind production systems is not just an idea.
Right.
It works. People are actually doing it. People are actually getting amazing success, like what Microsoft shared with us, reducing cycle time by 50% on the supply of equipment, as well as being able to move from 70% to 90 to 95% on achieving the delivery targets they had. So, I mean, I'm personally blown away by the stories that we heard today, to tell you the truth. But we'll see what people say through the poll. So back to you.
All right. Yeah, and actually, see, I might have to. Oh no, here it comes. Whoa, there it comes. Oh, look at that, right at the center, whip. That's great. A big shift in thinking. Absolutely. 5 levers. Oh man, you guys are getting it all. Behaviors. Absolutely. Little's law. That's great. Here we go again. Production systems. Awesome. Yeah, and while this is bubbling up, I can't resist, you know, working with PPI. If you're interested, there's a lot of information on the website. We would love to have your involvement. You know, we supporting both academic efforts and industry efforts and training efforts. So keep that in mind as you're considering what you're gonna do tomorrow. Variability. Wow, yeah, you guys are hitting all the high notes. Senior management support, contractors and vendors. WIP, variability, production systems, 5 levers. That's pretty much it. Wow, that's really cool. What do we got there? No manual, provoking culture. I like that. Time well set, spent, optimization system, mathematics space. Indeed, that's a part of the operations science. SPS, robotics, dynamic modeling. Awesome. All right, we're just about there. We got another reload. Oh, that's 22 folks. Thank you so much for your input there. It looks like you're catching the you're picking up on the concepts. Definitely. That's great to see. Were there any questions, Roberto, before we go? We got a couple of minutes.
Kristen's here. I just want to say thank you guys all so much for attending our theme 1. I think you know, we had a lot of great stories, as Ed and Roberto mentioned, and hopefully you guys learned something. We do have one more session after this. It's a panel on how does PPM fit with other project management solutions. That will commence at 3:45, so in p.m. Central Time. So that's 15 minutes from now, depending on where you are. It will be a different link because we'll be closing this session and starting a new one. You should again have that link for that Zoom session either in your email that you received, or you can go to the PPI website and it's on there as well. So thank you guys very much, and we will see you shortly in the final panel.